Okay, this is question 5 from the Limpopo June 2019 question paper. It's also from the Department of Education's 2015 paper. Define the term magnetic field. This is also a definition you have to learn from the exam guidelines. It's a region in space where a magnet or a ferromagnetic material will experience a non-contact force. Write down 4 properties of magnetic field lines. Well, the field lines never cross. Okay. They have a direction, and then you must say the arrows show the direction, and you can say from the north to the south pole. The field lines travel from the north to the south pole. Then the more dense the field lines, the stronger the field. And then what is the other one? I think these two are 2. The arrows show the direction of the field, and then the field runs from the north to the south pole. I think that is your 4th one, where how you state that there is which is the direction of the field. So what general term is used to describe materials that are easily magnetized? You can only magnetize ferromagnetic materials. So sometimes if it's easily magnetized, it's often a soft magnet, but here they're just looking for the term ferromagnetic. The diagram below shows the magnetic field pattern of 2 identical bar magnets with A, B, and C, D. So here's A, B, and C, D. So this is the repulsion diagram. You can see that these field lines, if these were having opposite poles here, there would be attraction and the field lines would run from one magnet to the other. But the field lines are exiting the magnet and they're trying to avoid each other. So what important information is obtained about B and C? Here is B, here is C. B and C have the same polarity because remember, like poles repel. Remember to stay poles and not charges when we deal with magnets. A small piece of magnetic material is placed at point X exactly in the middle of the arrangement. Will the material move? Now, what is a field line? What is a magnetic field? Okay, a magnetic field is a region in space where a magnet or a ferromagnetic material will experience a force. Is there any field at X? Can you see a field line at X? There are no field lines at X. And the field lines show you where there's a field where a ferromagnetic material will experience a force. If there's no field, there can be no force. And if there's no force, there is no movement. So the answer is no. If there's no field, there's no force. A small compass is placed at point Y. The north pole of the compass points away from D. Do the field lines around bar magnet CD point from C to D or from D to C? Give a reason for your answer. So now in the memo, they say to you that this is a south pole. They are wrong. It's got to be the north pole. If you have a look here at all the diagrams, they show you the needle of a plotting compass is pointing to the south pole, so it's coming out the north pole. Look at here, north pole, the magnet is pointing away. North pole, the magnet is pointing away. So here the magnet's compass needle is pointing away. So this tells me that the field line is going from D to C because D is a north pole. So if you have a look at the memo is telling you something different than what the literature tells you. The literature says the needle is pointing, showing the direction of the field, which runs from the North Pole to the South Pole. Give a reason why the Earth's magnetic field is important to our existence. It shields us from solar flares or solar radiation. Remember, the Earth emits that radiation which is dangerous to human life because it's ionizing high energy radiation, but it is deflected by the Earth's magnetic field, so it's saving us from frying to death.